Hi, welcome back. So I've got here on my screen the graphs of cosine and sine. And what I want to do is talk you through some terminology. So, first thing I want to point out is that there is a consistent distance between the humps. And it doesn't matter if we're talking about the peaks or the valleys. This distance on a repeating function like this is called the period. And you can look at a graph and see what the period is. And later we'll learn how to look at an equation for a shifted or adjusted or transformed function and know what the period is. But for both sine and cosine in their natural forms, the period is 2 pi. What that means is that the cosine of an angle is equal to the cosine of the same angle plus or minus actually any multiple of 2 pi. And the same thing is true for sine. It's probably easier to see it on sine because every 2 pi, actually every pi, the function goes through 0. So that's the other thing I want you to notice, is notice that there are 2 x-intercepts per period. This will become more important later. But for both sine and cosine, the function crosses through 0 twice in each period. Both functions have got the same domain and range. So the domain for both sine and cosine is all real numbers, meaning we can plug any x in and we're going to get a valid result out. The range for both sine and cosine, and remember range is the range of y values the function can take on. The range is -1 to 1. Okay. We call both of these graphs sinusoidal because they have the same basic shape, even though cosine starts in a different spot at the x-axis. They're still sinusoidal. Both sine and cosine are sinusoidal. Now there's one other difference though. Cosine is what we call an even function. And what that means is, notice here, notice that there's symmetry across the y-axis. So if I were to look at, for example, negative, so let's say this is negative pi over 6, and this is positive pi over 6. Notice that the y coordinates are the same for both of those points. What that means is that the cosine of negative x is equal to the cosine of x, making cosine an even function. If we go through the same exercise for sine, this would be negative pi over 6. This would be positive pi over 6. We can see the values are the same in magnitude but opposite. The y values are the same in magnitude but opposite in sign. What that means is that the sine of negative x is equal to negative sine x, making sine an odd function. Now remember, last chapter we discovered that the cosine of pi over 2 minus some angle is equal to the sine of that angle. We can rewrite this to say that the sine of theta is equal to the cosine of theta minus pi over 2. If you remember your transformations, this suggests that we can shift that the cosine function is really the sine function shifted pi over 2 units, or rather the sine function is really the cosine function shifted left pi over 2 units. And in fact, that is the truth. That is the relationship between these two curves. Okay, so this is pretty much all you need to know about the graphs of sine and cosine. We'll come back in a couple of minutes. We'll come back with the next video and talk about the relationship between a point rotating around a circle and the graph of the functions. But I need to give you one more piece of terminology. I almost forgot. This distance from the midline, so the line around which this curve oscillates, is called the midline. For a natural sine and cosine, the midline is, of course, the line y equals 0, and the midline is a line. So we want to write the equation of a line whenever we're talking about the midline. The distance from the midline to a peak or from the midline to a valley is called the amplitude. And for both for natural sine and natural cosine, the amplitude is 1. Okay, we're going to stop this here, and I'll be back with a subsequent video to talk about how we can solve a problem and some details about the amplitude. So I'll talk to you soon. Bye.